Welcome to the AI Research Roundup. I'm Alex. Today, we're looking at a paper from the Hugging Face trending list, published on August 2nd, 2025, about 3 days ago. It introduces a new framework for personalized AI safety that achieves an 86.2% win rate against the base SDXL model. The paper is titled Personalized Safety Alignment for Text-to-Image Diffusion Models, and it offers a really compelling solution to the one-size-fits-all safety problem in AI. The authors do this by creating a new dataset of user safety preferences and then integrating those preferences directly into the model's generation process. Also, the authors shared their official implementation on GitHub. If you check it out, you'll find everything needed to get going, like scripts for training and inference, evaluation tools, and even their pre-trained adapters for stable diffusion and SDXL. It's a very complete repository for anyone wanting to experiment. Alright. So this figure gives a great visual overview of how personalized safety alignment works. On the left, you can see different user profiles, from a healthy adult to a young child with depression. For concepts like hate and self-harm, the model's output, shown in the middle, dynamically changes based on that profile. More resilient users see more permissive content, while vulnerable users get filtered results. This is in stark contrast to the original model's single, unaligned output, shown on the far right. Building on that idea of user profiles, this visualization shows how those profiles are represented mathematically. Here, the authors took their 1,000 simulated users and plotted them using a technique called TSNE. Now, TSNE is a way to take complex data, in this case, a user's safety preferences, and display it in 2 dimensions so we can see patterns. And as you can see, the users form these distinct, color-coded clusters. This separation is crucial because it shows that user preferences can be grouped, which is what allows the model to learn these different safety boundaries. This table then details the new dataset the authors created, called SAGE, by comparing it to other safety benchmarks. The key takeaway is in this last row here. Unlike the others, SAGE is the only one built with user-specific data, 1,000 profiles to be exact. It also has the highest resolution images and the most safety concepts. The final column shows the IP, or inappropriate probability, which is a baseline measure of harmful content in each dataset. This rich, user-focused data is what makes the personalized safety possible. So how did they actually use that SAGE dataset to train the model? Well, this diagram lays out the entire training pipeline. At its core, the model architecture takes the user's profile and converts it into a numerical user embedding. This embedding is then fed into the main image generator, the denoising UNet, alongside the text prompt. The key innovation here is the use of a lightweight cross-attention adapter. Cross-attention is a mechanism that allows the user's preferences to directly guide the image generation at each step, making sure the final picture respects their boundaries. Okay, so let's look at the results for the SDXL model. This table compares personalized safety alignment against other methods. The key columns are inappropriate probability, where lower is safer. FID, which measures image quality, so lower is better there too. And Siegel score, which checks how well the image matches the prompt. Higher is better. The standout result is this bottom row here. PSAL5 consistently achieves the lowest, and therefore best, inappropriate probability scores. This shows a clear win for safety, even with a slight trade-off in image quality. And this figure gives us a fantastic qualitative look at those results. Each row represents a distinct harmful category, from hate to violence. If you look at the baseline methods on the left, like safety DPO, you can see they often struggle, leaving significant harmful details in the images. In contrast, look at the columns for personalized safety alignment. As you move from the lighter L1 setting to the stronger L5, the model progressively scrubs the harmful content, while trying to preserve the core scene. This really visualizes that controllable trade-off. So what this all comes down to is a powerful demonstration that one-size-fits-all safety is not enough. The personalized safety alignment framework shows that by integrating user profiles directly into the generation process, we can build AI systems that are not only safer, but also more responsive to individual needs. That's it for this episode of